Yeah. Today we're going to see about long short-term memory. So it means LSTM. First, you have to know short-term memory. Okay. So guys, in your school days, you people are studied 10th or 12th. Have you remember your marks? Have you remember your SSLC and HSC marks? Yes or no?
Yeah.
No, not the individual subjects. I don't remember
You don't remember,
all of them.
but the total you remember, right?
Yeah, I remember the total.
I'm asking that only. So, have you remembered your ninth, eighth marks?
Question no.
No. So these are the not important. So then only we forgot the memories. Okay. So whatever we want to remember the memories like 10th marks or 12th marks and college CGPA like that wise. So we have to store the short term memory. Is these guys, these are called short term memory. If you have remember long period of time, so we call it as long short term memory. Okay. Have you understood the difference? So short term memory is you are stored as short temporary memory, so you have remember as a long period of time, so then only we call it as long short term memory. Okay, so come to the point. So we call it as this is a long short term memory and this is short term memory. Okay, so now you have to assume that guys, now you people are studying 11th standard. Now you people are studying 11th standard. Okay, so now you people have a memory, right? So you have a ninth mark and 10th mark also, right? Yes or no?
Yes.
Yeah, yeah.
Yes. And that time you people are remember both ninth and 10th mark. Okay. So come to forgot gate. So here we are using sigmoid. The range is 0 to 1. Okay. So if you want, you just keep the memory. If you don't want, you just forgot the memory. Okay. Just forgot it. Okay. So in forgot gate, only forgot here we will only forgot the memory. So in which one you will forget, like ninth mark or 10th mark? Which one you people are keep? Which one you people are remove from here?
Ninth marks.
Ninth mark, because it's not mandatory to important. So you just keep the mark as a 10th mark. Okay, but in forgot gate only we will forget the value, only we forgot the content. Okay, so come to input gate. Here we are using sigmoid 0 to 1. Here we will keep the memory, here we will keep the memory, just remember the 10th mark. Okay, so in tan h also we have three range: 0, -1, 1. Okay, so 1 is keep and -1 is forgot and 0 is neutral between two range, right? So if it is needed and not necessary, just we will keep as a neutral, so that is called tan h. Have you got my point? So all the memories will be stored as a long short term memory cell. So okay, this is the updated cell. So this is stored as a long term memory, so it automatically add here. Okay, finally I'm just asking the output. You people are have to, if you are remember as a long short term memory, then only you will return the answer. So if you have a short term memory, then you have also answers. Okay, so now you people are studying 12th standard. Your teacher is asking, so what's your 10th mark, what's your ninth mark? So now you people have forgot the ninth mark and you people are remember the 10th and 11th, right? Yes or no?
Yeah.
Hmm. So guys, these are the main things you have to understand the gate concept. So this is the LSTM cell. So we call it as LSTM cell, but you have to understood these things. So how it's working. So first one is forgot gate. So forgot gate is to remove the unnecessary thing. Okay, not important. Okay, and the next one is input gate. It store the informations, and the output gate is to you can retry the outputs from the output gate. Okay, have you understood this concept?
Yes, Vasant.
Just take a snap. we will go to another. Okay, so if you are asking ChatGPT, I love books, it automatically summarize the paragraph, right? So it automatically summarize the paragraph, right? So if you are giving the I love books, so it automatically generate the texts, right? So it already stored their memory, right? So in ChatGPT already they have sentences or embedding and stored into the vector database, so it's automatically we can retrieve from the ChatGPT. So just a minute, I'll show you another diagram. Just take a snap. See here. So this is the best example for LSTM text generations, and normally we will give the chat GPT text as a I love, so it automatically generates. It depends on your willingness, so it depends on I love to play football. Okay, so now tell me, so the start word is what? What's the start word? It's I. What's the current word now? Input as I. So in forgot gate there is no past memory, and come to input gate we will add as a I as a memory. Okay, in cell state we will
First,
combine the I. So what's the output now? So I. Okay, so guys, for best example, on our school days and college days, our teachers are dictating, right? So they are telling the answers and we will write our notebook, right? Yes or no?
yes.
So that's a short term memory or long short term memory?
When we are writing in the class, it is a short-term memory.
Yeah, we just keep on mind as a 2 3 words, right? So if I'm telling, I'm dictating, so list is a collection of you people are writing, so you people are say and writing, right? So list is the collection of, and I'm said like another sentences is heterogeneous or homogeneous data items, and you people are writing, and again I will complete the sentence. You, that's a short term memory, right? Yes, but so long short term memory is too different, so it automatically stores permanently. Okay, so what is the next sentence prediction? So the next sentence prediction is love. So this is our current word, and what is the forgot? So guys, in forgot gate we will keep plus forgot. Okay, here we have keep plus forget. Okay, so what is the keep memory here? I. Okay, so what is the input word? Love. So now combine this both. So what is the cell state now? I love. So what is the output here? Love. So the next sentence prediction is 2. Okay, so come to here. What is the keep memory here? Forgot, in forgot gate I love. So what is the input now? 2. Now combine these both things. So what is here? I love 2. What is the next? The output is 2, and the next prediction is play. Okay, the next prediction is play. Now the previous memory is what? I love 2. So now the input is play. So it's like a teacher dictating the word, like this is best example for us, guys. I love to play. Okay, so now you people are writing the cell state I love to play, and the next output is play. Okay, and the prediction is football. Okay, now what you people are remembered in previous, I love to play. Now you people are adding input as a football. Now you people are combining these both things. I love to play football. So what is the output now? Football and end. So it automatically generates one by one, guys. We got my point. This is the best example. You people are applying that LSTM cells. It's easy to remember. Have you understood? Just take a
Yes.
snap.
Yes, Prashant.
Just take a snap. Is have you taken up?
Yes,
Yes,
Prashant.
taken.
Okay, I'll show you another image. So guys, this is a recurrent neural network. You people are seeing in deep learning concept, you people are seeing neural network. So that means it's a forward direction. So first one is input layer, the second one is hidden layer, and the next one is output layer. So that is a forward pass. and but in recurrent neural networks, so all the memories will be stored as current cell state. It means it's already stored as a hidden layer. Okay, so this is the best example for teacher dictating. So like, I love playing football. Okay, so first teacher will say told I, so you people are just remember the I, and this she will told another word, so you people are remember the both word, right? I love. And the next one again you will adding the playing, so it also we want to remember these things. And now in our mind we have I love playing football. So now what's your output now here? So I love playing football. Do you have any doubts? So in recurrent neural networks, all the memories will be stored as a hidden state only, guys. Have you got it?
Yes, Vasant.
Just take a snap. Have you taken?
Yes.
Okay. Okay, so guys, come to the class. So I already told, right? So recurrent neural network, it means long short-term memory. So long short-term memory is a type of recurrent neural network. So recurrent neural network is a short-term memory, but long short-term memory is a long-term dependency. Okay, so it is designed to remember the long-term dependency and sequential data by using what they are using, memory cells and gating mechanism. So in natural language, they are widely using for natural language and time series forecastings and speech recognitions and stock market prediction. Now, so come to the point. So what is RNN? Just now I explained, right? So RNN is a type of neural network. So this is mainly designed for processing sequential data. It may be text or time series or speech or anything. So it's not like a regular neural network. So it treats input as a independently. So RNN, what it does? So RNN remembers the information from previous steps using loop, right? So I draw the diagram, right? Using loop, it remember the memories. It's right. So it were using for order and context matter. Okay, so come to here. Why LSTM over RNN means? So here we are applying vanishing gradient. So vanishing gradient means it can't learn long dependency. And come to short-term memory, it is a short-term memory only. So RNN is a short-term memory and not effective long sequencing. So we will not using long sentence predictions for RNN. So then only we are using the LSTM to solve the remember the relevant data for long period of time. I simply said that. Have you got it, guys? Have you understood now? Do you have any doubts here? LSTM and short-term memory and RNN. Do you have any doubts here?
No, Vasant.
Okay. So come to the next one. So I already explained the diagram, right? So you people are already know. So this is used for to display the image. You just do this code. You just take the image from the website. Okay. You just search the LSTM cell. It's like the similar structure image will be there. So it's my image format is lstm.webpn. So if your image is png jpg is it's enough. Okay, have you got it? So I already told, right? So in LSTM unit, so we are using a forgot gate. So forgot gate is what it designed. So it designed the information to discard from the previous cell state. So this is the formula of forgot gate, guys. We no need to memorize the formula, just you have to know this. Okay, and the next one is input gate. I already told, right? So it store the new informations in the cell state. And what is cell state means? It combine the forgot and input gate. So this is the cell state. So this is the cell state. It combining both these things is right. So it combining both these things, forgetting and input gate. And the next one is output. So the output gate is decide the output to find the output also current cell. Okay, we just applying so forgot gate and input gate and candidate gate and cell state, and another one is output gate. Okay, so have you understood, guys? So this is the formula. Like, so what here we are applying in forgot gate, we are using sigmoid. So what we people are applying here, sigmoid and tan h, so then only we will give sigmoid and tan h, and here we will combining all these things, then only they are giving the joining word. And the next one is here we people are finding the tan h and sigmoid, the same thing here we are applying. Okay, here also weights, here also we have weights and x and x and weights and bias also. You just here see here xt is the input, so current time, so this is the input current time. Okay, just apply the example guys, I already told, right? So now you people are studying 11th standard, so this is the current, and you people are remember the 9th and 10th mark, right, in previous. So in hidden state, so ht minus 1 is a hidden state, and the ct minus 1, so it is a cell state, ct minus 1, so it is a cell state from previous one. Okay, and another one is see here, so ft is a forgot gate, and it is the input gate, and c cap is the candidate, and ct is the updated cell state, and ot is the output gate, and ht is the hidden state. So the wr mentions as a weight matrices, so weight matrices which are using input forgot gate, input gate, and candidate gate, and output gate. So these are the bias, and you people are know sigmoid and tan h, and star is the multiple element, so then only they are giving the star. Okay, so the same thing I already explained in the previous diagram. Okay, just remember these things. Guys, here we will using one use cases for stock price predictions using LSTM concepts. I tell you, just you people are download this one, it mean install this one, open your command prompt and just type pip install yfinance, it automatically install. Okay, and come to next one, you have to write the libraries what we needed. So numpy, so it's used for fast mathematical calculations, and pandas we are using for data visualize, data analyze, and data manipulations. In visualizations part we are using matplotlib, and here we are importing yfinance, so this is one of the data sets for apple. And another one is sklearn for pre-processing, here we are using min-max scalar, so for scale value. And comes to TensorFlow Keras models, we are using sequential and dense and LSTM input. I'll tell you guys, just imagine, so it's the same, you people are drawing the diagram, right? So first one is input gate, and sorry, first one is input layer, so now you are using 15 LSTM cells, and the last one is output. I'll tell you, they see here. So now you people download, you already installed the yf finance, so you just download this one, so it means apple company, so it starts date from here and ends with here, it automatically adjust. Okay, so then only we will give true. And the same thing guys we are using here. And data column, data means close column, so this is the close one, so we just using copy method, we just copy and drop the not available. Okay, so it automatically we will using here. And in data, so now we are checking guys, what are the table format will stored as a data format. So see here, so this is a close price. So guys, now you people are making manufacturing the apple mobile phone, just imagine, so this is our close price, this is our high price, and this is our low price, and this is the open price, and this is the volume. Okay, now I will give one scenario guys, just assume that you people are making a lemonade, you have a lemonade shop since 1 month. So now how to decide to prepare today's lemonade, how many glasses you people are making lemonade? I'm just asking. Yesterday, you people are not okay. You can assume lemonade or fruit salad. So many peoples are selling the fruit salad, right? So in small container they are selling the fruit salad, right? You have to assume that. So yesterday we are sold 50 salad boxes. Then how many salad boxes you people are prepared today? How many salad boxes you people are prepared today?
Yeah, more than 50.
More than 50 depends on we can take last 1 month data set, Alka. Yesterday we sold 50, and in day before day we sold 40, and in day before we sold 35, and day before we sold 25, and day before we sold 40. Like depends on data, right? Is Alka?
Yeah. Yes.
So now we are manufacturing the mobile at 8th January, but we want to see all the datas before 8th, right? So before 8 we will see all the data, right? Yes or no?
Yes. Yes.
Yeah, then only we will predict. You just take, these are the x, so these are the x independent variable, and this is the y, it's a dependent variable. So 8 depends, what are the columns 8 depend, guys? What are the rows 8 will depends? 8 depends date 2, date 5, date 6, date 7. These all the dates are we call take as a x. Okay, just assume that. So we will just take the close price only, we will just take the close price only from the given data set. We will just take the close price only. See here we are using normalized data, so min max scalar, now we are fitting the normalizing data. Now see the output, guys. So what is the number here? 24 point something, right? And here 23 point something, and here 23 point something here. Now see here, so all are in scale value, right? So all are in 0 to 1 scale value, right? Yes or no?
Yes.
Hmm. So now see here, guys, we here we only separating the x and y only. Okay, I already told, right? You just take as a 60 days, guys. 2 months you just take as a 60 days, then only you will predict the 61 day, right?
Yeah.
Yes.
Yes.
So we are taking time step. So this is a 60 days. Time step is a 60 days. So then our range is I starts from 60, and this is the length scaled data. You just asking what is the length now here? 2515 rows. So this is our length. So now imagine that 60 to 2515. Okay, now we people are appending the x. Okay, depends on scaled data. Now see here, what is I now, guys? This is the I. So what is I? 60, 61, 62. What is the number now? I 60, right?
Yes.
What is the time step here?
60.
60 minus 60, what is the answer?
0.
0. Now see here, what is the I? 60. Okay, so this is a, guys, before comma we call it as row, after comma we call it as column. Now tell me, so we have 60 rows, we have 60 rows in single column. It means we have like this wise, we have 60 rows in single column. Okay, so if you know the first 60 days, then only your output is predicted as a 61st day, right? Yes or no?
Yes.
Then only we will give the I comma 0. It means 60 comma 10. Sorry, 16 comma 0. So now we will find the output, right? So the same thing we will append one by one as a array format. So x and y. You just check here. What is the x shape? What is the y shape? Have you understood, guys? Have you got it?
Yes.
Yes.
Gautam, now we are selling the fruit salad for 1 year. Okay. So have you take the 1 year data set or 60 days data set? Which one is suitable for you?
The last 60 days will be suitable for me.
Then after the 2 weeks, we will sell the fruit salad. So now how many data you want to predict? Last 60 days,
Last
right?
six,
Yes,
last 60 days.
yes. Depends. It change depends on day by day, right? Have we understood
Yes.
where we are using LSTM? So whatever the things we know needed, we just forgot it. One whatever the things we needed, we just remember the things. Have you got my point?
Yes.
Yes. And now you people are reshaping that. So x is the your input. So x is your input. Now you people are giving the x shape 0 and x shape 1. So x shape 0 means what? X shape 0 means 2455. So it means so first one is samples. So this is the x is our sample, and this is our time step. So this is our what? Time steps, guys. This is the sample and this is the time steps, and this is our feature. Have you got my point? So in this bracket, the first one is samples and the X shape one is the time steps. So this is the X shape one is right. X shape of one, right? One index. So one index is a time steps, and the comma one is this is the features. Okay. How many days we were predicting, guys? This is we have this much of data, but we only takes the 60 days. We will predict for one day, right? Have you got my point? Yes.
Yes.
Hmm. Guys, here we will not give us a train test split. We will take as a first 80 percentage. First 80 percentage of data as the X train, Y train. Remaining data will be, we will take as a X test and Y test. So see here, how to find the split. It mean you want 80 percentage means you just multiply into len of x into 0.8. You will get a 80 percentage. So now the split is what? 1964. So if you want, this is the split 1984. Sorry, 64. So you want all the columns. You starts from 0, but the starts with what? 1964. Here starts with 1964, ends with, it takes all till destinations. Have you got my point? Yes. Is
Yes,
that no?
yes, yes.
We just train test split the model. We are just checking how many will going for training, how many will returns for testing. So 80 percentage of data will be going for training, remaining 20 percentage is going for testings. Okay, now we plot, guys, we no need to draw the diagram as a LSTM. We just apply our code, right? So here you can directly write the shape. So what is the exchange shape 1? X train shape 1. So what is the shape now here? 60 days, right? 60 days in
Yes.
one column, right? So it means 60 rows in one column, right? So you have to draw as a 60 neurons. You have to predict the output. Wait a minute, I'll show you the diagram. Guys, imagine that. So this is our hidden layer. We no need to see the concepts. So this is our hidden layer. Just assume that this is our input layer. How many days we people are predicting? 60 days, right? So just take as a neuron. So this is a 60, and this is a 1, and this is a 2, 3, 4. We want to predict the 61st day, right? So this is our output, right? Yes or no?
Yes.
This is a diagram. We people are here. We are using 50 units. 50 units. So we will use this diagram, these architecture as a 50 times. So we are using the architecture as a 50 times. Then predict the output. So this only we are writing in our code. Have you got my point? So our final output is 1, right? Here we are using loss, so mean squared error. We are checking the loss errors, and optimizer we are using Adam. Okay, here we are applying just epochs as a 5, and batch size is a 64. Now verbose is 1. Verbose is 1 means it automatically shows the green line. If you are using 0, it will not shows the green line. So now you people are checking the loss, and you can predict the output. So predict x test means you can easily predict the output, right? So in scalar inverse transform, you just give the predicted one. If you are asking predicted price, so this is the shape of predicted price, and this is the shape of actual price. So in actual price, we are using inverse transformer, and you just give the y test and reshaping here from -1 to 1. So what -1 represents? Last number, right? So -1 represents what? Last number of rows, right? Yes or no? So -1 means 491 rows. It means 491 rows. So now you people are seen as a graph. Actual value and predicted value. See here, actual values as a blue color and predicted also blue color. So the prices increased or decreased?
Yeah, it's
Increased.
increasing.
Hmm. If you people are selling the mobiles or manufactured mobiles, in every years it's increased, right? So never it will decreases the cost, right? Yes or no? This is the stock price predictions using LSTM. Guys, do you have any doubts in these concepts in LSTM architecture? Is Alkan Gautam, do you have any doubt?
No.
Hmm.
No.
Okay, okay.